The Atlantic Ocean, the name itself, brings to mind crashing waves, epic voyages, and coastlines stretching to the horizon. It covers about 20% of our planet's surface, a vast, powerful force that has shaped not just our world, but the course of human history. We think we know it. We sail its surface, fish its waters, and fly over its immense blue expanse without a second thought. But that feeling of familiarity, it's a grand illusion. The shimmering surface we see is just the skin of a much deeper, more mysterious entity. What if everything we see is just a mask? What if the true Atlantic, the world that exists in eternal darkness and under crushing pressure, is more alien than anything we could imagine? Scientists are just beginning to pull back the curtain on a world of colossal mountain ranges, bizarre life forms that defy biology, and secrets that have been hidden for millennia. So, what's actually at the bottom of the Atlantic?
The ridge was first charted during the Challenger expedition
in the 1870s.
Scientists suspected something extraordinary hidden beneath the waves.
Modern sonar changed everything, revealing an enormous mountain chain hidden beneath the ocean.
Yet this landscape is far more than a collection of underwater mountains.
It marks the boundary between immense tectonic plates. A seam where continents continue to drift apart. A process that is still shaping our planet today. This is the birthplace of the Atlantic seafloor. Fresh oceanic crust forms here continuously, filling the space between separating plates.
The North American and Eurasian plates drift apart by roughly 2.5 centimeters each year,
a process known as seafloor spreading.
Created by molten rock rising from Earth's mantle,
filling the space between separating plates.
The North American and Eurasian plates drift apart by roughly 2.5 centimeters each year, a process known as seafloor spreading.
One of the most powerful geological forces on Earth. Constant earthquakes continue to reshape the ridge. Volcanic eruptions create entirely new sections of ocean floor. Even today, the Atlantic Ocean continues to grow. Yet many mysteries remain hidden here. Rows of tiny holes, arranged with remarkable precision.
In 2022, explorers encountered something unexpected.
Almost perfectly spaced. As though created by some unknown engineer. Scientists have named them Lebensspuren, German for life traces. German for life traces.
Elsewhere, drilling expeditions uncovered secrets buried deep within the mantle. The process also locks carbon dioxide into solid rock. Some of the deepest mantle rock samples ever recovered.
Revealing a process known as serpentinization. A reaction capable of producing molecular hydrogen. An energy source that can sustain life without the sun.
Entire ecosystems may depend on these reactions. The process also locks carbon dioxide into solid rock. The process also locks carbon dioxide into solid rock. This is not a dead landscape.
It is a world of constant creation. A place where Earth continually renews itself. A landscape that helps us understand the mechanics of our planet.
And perhaps it may even hold clues to the origins of life itself. Moving away from the dramatic creation of the Mid-Atlantic Ridge, we arrive at a landscape that seems to be its complete opposite.
These are the abyssal plains. Vast, seemingly featureless expanses covering huge portions of the Atlantic Ocean floor.
Most lie between 4,000 and 6,000 meters below the surface.
Some of the flattest places on Earth.
Stretching for thousands of kilometers, like a submerged desert. Touchdown on the seabed isn't a gentle arrival on a sandy plain.
Instead, we find ourselves at the foothills of the largest geological feature on Earth.
This is the Mid-Atlantic Ridge, the longest mountain range in the world. Stretching over 16,000 kilometers from the Arctic to the very tip of Africa. It's a colossal spine running right down the middle of the Atlantic. A feature so vast, it dominates the center of the ocean basin.
Though almost entirely submerged, its peaks are monumental.
Some rivaling the Alps in height.
And a few even break the surface, forming volcanic islands like Iceland.
And the Azores.
The ridge's existence was only first charted during the Challenger expedition in the 1870s.
The ridge's existence was only first charted during the Challenger expedition in the 1870s.
But the Mid-Atlantic Ridge's true, staggering scale remained hidden.
It wasn't until modern sonar mapping that the ridge revealed its true size. Modern sonar mapping uncovered one of the largest structures on Earth.
But the Mid-Atlantic Ridge is far more than a chain of underwater mountains.
It is the seam where tectonic plates are being pulled apart. This is the birthplace of the Atlantic seafloor. As the North American and Eurasian plates separate, molten rock from the Earth's mantle wells up to fill the gap, creating fresh oceanic crust. As the North American and Eurasian plates separate at about 2.5 centimeters per year.
Molten rock from the Earth's mantle wells up to fill the gap,
creating fresh oceanic crust. This is the engine that continues to build the Atlantic Ocean. It's a hotbed of geological activity. Marked by constant earthquakes. And volcanic eruptions. Exploring the ridge is a monumental challenge. Scientists are starting to map its jagged peaks and rift valleys. In 2022, NOAA explorers made a baffling discovery. They found rows of tiny, perfectly aligned holes in the sediment. The pattern appeared almost deliberate. They looked almost man-made. A mystery that remained unsolved. Scientists have dubbed them Lebensspuren, German for life traces. Researchers suspect they may have been created by some burrowing organism. But nobody knows for certain. Yet the ridge still had even deeper secrets to reveal.
Even more profound discoveries emerged from drilling expeditions. Scientists extracted some of the deepest mantle rock cores ever obtained, hundreds of meters long.
From a site on the ridge known as Atlantis Massif.
Analysis revealed a process called serpentinization,
where seawater reacts with mantle rock.
Releasing molecular hydrogen.
This chemical reaction provides a source of energy capable of supporting life completely independent of the sun.
It even locks away carbon dioxide into solid rock. The ridge isn't a dead landscape. It's a world of constant, violent creation that holds the keys to understanding the very mechanics of our planet. Leaving the silent plains, our journey now takes us to pockets of the seafloor that are anything but quiet. These are the oases of the deep, hotspots teeming with life so strange it forces us to redefine the rules of biology. Welcome to the world of hydrothermal vents and cold water corals. First, the hydrothermal vents. Found along the mid-Atlantic ridge, they appear as shimmering columns of water or billowing clouds of dark material. These are black smokers, underwater geysers where seawater, superheated by magma, erupts from the crust. The water can reach temperatures over 400 degrees Celsius, 750 degrees Fahrenheit, but the immense pressure keeps it from boiling. As this mineral-rich fluid hits the near-freezing seawater, the dissolved minerals solidify, creating towering chimney-like structures.
But the real miracle here is biological. With no sunlight, life found another way: chemosynthesis. Specialized bacteria harness energy from toxic chemicals like hydrogen sulfide to create organic matter. These microbes are the base of a stunningly dense ecosystem.
Clustered around the vents are giant tube worms, some growing over 2 meters long, with bright red plumes that filter chemicals from the water.
They have no mouth or stomach, hosting bacteria inside their bodies in a perfect symbiotic relationship. Swarms of ghostly white shrimp and specially adapted crabs crawl over the smokers.
Since the discovery of the first vents, hundreds of new species have been identified, the vast majority of which are found nowhere else on Earth.
Around the year 2000, explorers in the mid-Atlantic found a different type of vent system, nicknamed the Lost City.
Its ghostly white spires are formed by a chemical reaction, not volcanic heat, and some scientists speculate this is the very... But vents aren't the only oases. The Atlantic floor is dotted with thousands of seamounts, underwater mountains that act like islands of life. Their rocky slopes are the perfect place for another incredible ecosystem: cold water coral reefs. Unlike their tropical cousins, these corals don't need sunlight. They are filter feeders, capturing marine snow.
They are vital nurseries and spawning grounds. However, these ancient ecosystems are incredibly fragile. Our journey now descends into the most extreme environments in the entire Atlantic: the deep-sea trenches. These are the deepest scars on the ocean floor. Here, one tectonic plate is forced under another. This process creates chasms of unimaginable depth.
The undisputed king of the Atlantic depths is the Puerto Rico Trench. Located just north of Puerto Rico, it is the deepest point in the entire Atlantic Ocean. It plunges to a maximum depth of nearly 8,400 meters, about 27,500 feet. If you could place Mount Everest at the bottom, its peak would still be submerged by more than a kilometer of water. The pressure here exceeds 800 times that of the surface. The equivalent of having dozens of jumbo jets stacked on top of you.
This area marks a violent boundary.
Where the North American plate is being pushed under the Caribbean plate,
making it a hotspot for major earthquakes. And tsunamis.
For a long time, the Hadal Zone, the ocean below 6,000 meters, was thought to be a biological desert.
But modern exploration has proven that wrong. The Brownson Deep. Finally giving us eyes in this alien world.
What his and subsequent robotic expeditions have found is a world populated by creatures that have evolved under the most extreme conditions imaginable.
Life isn't abundant, but it is resilient. Explorations have revealed strange new species of translucent snailfish, crustaceans, and other invertebrates. The creatures here are often pale or gelatinous. Their water-filled bodies help them withstand the crushing pressure. In this world, survival is not about abundance. It is about endurance. The trenches are the final frontier of the Atlantic. They are archives of geological history. They are also archives of biological history. Layer by layer, the trench records the story of the ocean. Even here, in crushing darkness, life persists.
This is a world almost completely cut off from the surface.
Every organism here is shaped by pressure, cold, darkness, and time. Each expedition reveals only a fragment of what may live below. Most of this Hadal world remains unseen. The Puerto Rico Trench is both a geological wound and a biological frontier. It holds secrets about the absolute limits of life. The deep-sea trenches remind us that the Atlantic still contains worlds we have barely begun to understand. The story of the Atlantic floor is also our story. For centuries, the surface was a stage for trade, migration, and conflict.
The bottom is the archive of that history.
It's a vast, silent museum dotted with countless shipwrecks.
From ancient galleys
to the most famous of all, the RMS Titanic, which lies at a depth of 3,800 meters. Over time, it's become an artificial reef, its steel hull being consumed by bacteria while providing a home for deep-sea life.
There are also the legends, like Atlantis.
And the modern myth of the Bermuda Triangle, which, despite its reputation, shows no evidence of anything beyond natural weather and heavy boat traffic.
Our relationship with the deep is changing. For millennia, it was beyond our reach.
Now, we're developing the tools to explore it.
Autonomous underwater vehicles are mapping vast swathes of the seabed.
Part of the Seabed 2030 project that aims to map 100% of the world's ocean floor by 2030.
Sophisticated ROVs like NOAA's Deep Discoverer can dive to 6,000 meters, acting as our hands and eyes in the deep. Streaming high-definition video back to scientists in real time. But as our reach extends, so does our impact.
The deep sea, once thought to be insulated from us, is now facing unprecedented threats. The ocean has absorbed enormous amounts of heat and carbon dioxide, causing temperatures to rise and leading to ocean deep sea fishing, particularly bottom trawling,
can devastate ancient coral reefs that take millennia to grow back.
Some damage in the deep may outlast human memory.
And on the horizon is the controversial prospect of deep-sea mining for minerals on seamounts and vent fields,
which could cause irreversible damage.
Our growing presence presents us with a profound choice. Will we be explorers or exploiters? The human story is now being written on the very bottom of the Atlantic. And the next chapter is up to us.
From the sunlit Sargasso Sea to the crushing darkness of the Puerto Rico Trench, our journey has revealed a world far more complex and mysterious than we could have imagined. We've traversed the longest mountain range on Earth, drifted over silent, abyssal plains, witnessed the impossible oases of hydrothermal vents, and marveled at ancient coral cities. But the most powerful realization is not what we know, but what we don't. As of today, over 70% of our planet's seafloor remains unmapped at modern resolution. We've mapped more of the surface of Mars than our own planet's deep oceans. What other life forms, what other geological wonders, what other secrets about the very origins of life are still waiting in the dark? The Atlantic is both an archive of our planet's past and a frontier for our future.
The greatest secret at the bottom of the Atlantic may not be a strange creature or a lost city, but a reflection of ourselves.